Hey, what's up everybody? Good morning, good afternoon, good evening, whatever time of day you are deciding to watch this video. This is a little tutorial on how to do the seasons and temperature variation lab. The directions are, listed within the lab, but I feel like doing a little video to kind of give you a walkthrough could be helpful. So a couple of like the main things we're going to work on today are looking at seasons and how basically the sun interacts with the surface of the earth. Timing wise, like hours of sunlight against various latitudes, the amount of solar energy coming in and actually being felt at the surface, as well as we're going to investigate temperature variation around the world as well. You're going to make a quick graph from this data, and you're also going to do some calculations within Google Sheets or Excel, just depending on which one you're working with. I'm going to show in Google Sheets, but if you're working in Excel, that's totally fine. The functions should still all be the same. Please reach out, as always, if you have any questions, comments, or concerns on how to work through this lab. My office hours are always open, as well as my email inbox, or you can text me. So please reach out if you're having difficulty with any of this, so I can help you in real time. So with all of that, this should be what you see when you open up Lab 4. My normal directions are up here and the general objectives. So what we're going to be doing is we're going to utilize a website. It's a really neat modules website I use for some of my various classes. And it gives you just a really nice sort of like visual of whatever sort of topic we are investigating. So when you open up this website, you have lots of options of modules, but we are going to, if you scroll down a little bit, we are going to be working with the seasons module for this first activity. So what you initially see when this pops up is an image of the sun and the earth. It's currently in oblique view. I personally prefer the top-down view. I just think it gives me a much better idea of what's happening. And then you'll also see this graph here over on the right side. So currently what is being shown, this blue line, this is hours of sunlight. So with the 90 degrees north on the top, 90 degrees south on the bottom, so these are latitudes on our y-axis, with the equator here in the middle. Some other things you're going to need to turn on for sure is the insolation curve. So this is now this pink line that has been put onto this graph. And notice now also the bottom x-axis has become visible. So we have solar insolation. Again, you can think about that as basically solar energy. What you can also turn on is a map, which pops up here on the right side. You can move it out of the way if needed. But again, this gives a really nice visual of where the sunlight is or isn't, depending on the time of day, right? So in this example, we have most of the Americas are in daytime going into evening, and much of Africa and Asia are in nighttime. You can also start a rotation of the Earth as well, which is again a nice, cool little visual. Not necessarily important for this activity, but it's just a nice visual. So what I asked for you to do is there is a table here, and notice that I have color-coded the variables that I want you to investigate. And what you're going to do is you're going to put the Earth into times of like sun angle in a sense, so winter solstice, spring equinox, summer, and fall. So what I've done is I've included an example of the estimated values for the winter solstice. So let me show you how I did that. So to move the planet, you're going to look at this little yellow triangle, and you're going to move that. So once you move that, then it moves the planet around the orbit. And you want to try to get it to where winter solstice is. Notice how the words get either are transparent and they get a little bit more opaque. You want to try and get it on the most opaque color, so like the strongest pink of whatever words, whatever time of year you're looking at. So how I would do this if I was using a computer screen and not showing on a recording is put up a piece of paper like at the variable or at the latitude, and go either up, like follow the blue line up where it crosses that latitude, and then follow the pink line down to the bottom x-axis where it crosses that latitude. So my little annotation thing here. So for example, for 90 degrees north, which is this little buddy, I'm going to where that blue line is crossing the top x-axis is at 0 hours of sunlight. So I'm like, okay, 90 degrees north, 0 hours of sunlight, beautiful. And then solar insolation, I would again follow this line all the way down and see where it crosses the bottom x-axis. And in this case, it's saying 0. And that makes sense, right? 0 hours of sunlight, 0 solar insolation, no brainer. But then when you get to the other lines of latitude, you're basically going to follow that same idea. But in this case, like say for 60 north, the blue line crosses right around here. I follow that up to the top x-axis. And where the pink line is crossing the 60 degrees north, I try to follow that down here. A common mistake that students will do is follow the actual path of the line all the way down, and that's not what you want to do. You want to see where it crosses, not a straight line, but you want to see where it crosses this kind of y-axis here, and then follow that to the subsequent top or bottom x-axis. Again, the pink line is going down south, or to the bottom, to the solar insolation. The blue line is going up here to the hours of sunlight. So that is going to be your task for this first part of the activity. And then I want you to summarize what you've observed. Once you finish that, then you're going to go back to the sun angle module. And with this one, we see a pretty Earth, and we're currently in March, and the map projection doesn't matter here. But what you are going to have to change is the month, and then what you're going to be doing is sort of clicking along each row. So there are 18 full rows, but you're only filling in kind of like every other one. So this would be row 1, row 3, 5, 7, 9, and then from here I make a little adjustment, so you go from 9 to 10, so we kind of, in a sense, kind of straddle, if you will, the equator in this particular case for this particular month. And then from here you go every other again. So this is row 10, 12, 14, 16, and then 18. So the numbers that you're going to be putting into now this table are going to be the numbers that you see on the left-hand side. So essentially, in this case, this one here, and then the numbers over here on the right. So this is what's coming in, and this is the amount of energy that's actually being felt at the surface. So you'll notice I've also color-coded a few of the cells here. The green is meant to be the equator, and the blue is meant to be either the tropics of Cancer or Capricorn, just depending on if you're in the northern or southern hemisphere, respectively. So that's essentially the idea here. You may find that the values are dang near the same, and that's sort of on purpose, but what you're going to be investigating as well is, again, these lines of latitude and where they exist or don't exist, right? So try to work your way through that as best as you can. So that's activity 1. Then going on to activity 2, we're looking at temperature comparisons, and this is where you're going to pull back up lab 2. Remember, in lab 2 we looked at latitude and longitude, and you investigated where 18 different locations are across the world, given their latitude, longitude, and also recall I gave you their elevation. So the elevation can take a big part into the average temperature and even temperature range, perhaps, of a given location. The idea here, generally, the higher you are in elevation, the colder your average temperatures are going to be. Think about, like, in the winter time in the Sierra Nevada mountains, there's usually snow on the Sierra Nevada mountains, and that snow stays there, but it's not as snowy, say, in the Central Valley or here along the coast, because it's warmer at lower elevations. So that's a way that you can remember that. And I have linked lab 2 in here a couple of times to remind you where that is. Obviously, you would want to go to the one that you completed to help you out with this. But essentially, we're going to do some hypothesizing a couple of times here. And then you're going to upload that same map that you did for lab 2 here. So I know it's a repetition, but it's also being able to put that map here so you can help with this hypothesis of which locations do you think are going to have the warmest or coolest average temperature or largest or smallest range. So a range is basically the warmest summer temperature compared to the coldest winter temperature. So for example, here in San Francisco, we don't have a very big range in average temperatures. Our warmest temperatures on average are in like September, October, and about like the low 70s. And then our coldest winter temperatures are around December, January, in like the mid 50s, right? So not a big range of temperature there, but some locations may have a much larger range. And that's what I want you to kind of think about here. And then why you think that might be the case. So what I've done for you instead of like having you do various functions in sheets, that's not really the purpose of this particular lab. It's a great practice if you want to practice this function. It's just the substitute function. It's a little bit arduous though. I have some separate videos kind of going through on how to do that. So you can search my YouTube channel if you wanted to find that, or if you're proficient in sheets and using functions, you can give it a try. But for sake of sort of brevity and for like less work on your end, what I've done is I've created this spreadsheet here, which you should be able to pull up. And what you're going to do is you're going to make a copy of this spreadsheet. Notice that there are actually two sheets here. There's the use this sheet tab and the substitute function. So this will give you an idea of the function that I used for each location to basically get rid of this degrees Fahrenheit symbol. It's just kind of in the way, and it then like Sheets doesn't visualize these or see these numbers as actual numbers. So it's just a little bit of like an annoyance, but I took care of that annoyance for you. So you're going to use this sheet and make a copy of it. And when you've had your own copy in your own drive or on your own device, then you're going to calculate the average and range for each location. And then you're going to put that into the lab. So once you've done that calculation, you're basically going to copy and paste those two columns of the average temperature and temperature range for each of your 18 locations. Below here, and I say in letter A, you're actually going to give me a copy of your spreadsheet so that I can see to make sure you did something right. Just so when I'm grading this and something is a bit wonky, I can see where something went wrong so I can give you proper feedback. So that's the method to my madness with that. Some students have given me really strange answers and I don't know what to say as feedback if I don't know what the heck you did. So that's the idea there. And then you're going to fill in this table with the actual results, which location actually had the highest and lowest average and the largest and smallest range. And again, I want you to think about why that might be. Then your last task before you summarize everything is you're going to make a simple bar graph showing just the three top locations in the southern US. So all the three only locations with the same latitude, 33 degrees north, but just of their average temperature and temperature range. So what you can do to do that is I've just made a different copy of the spreadsheet just to kind of show you exactly how to do this. These are not the actual values that you will see for these three locations. I just put in random numbers just so you can't copy and paste me or stop the recording and take a screenshot, right? So we're not doing that. But I still want to show you exactly how to make that bar graph. So what you're going to do is you're going to select the first four four cells in this first column so that our x-axis can tell us what locations we're looking at. And then you're going to hold the command key or control key, depending on your device, and then just scooch on over here to the average and range columns and select those values. Now, once you have the location selected and the values selected, you're going to go up to Insert and Chart. And see, that didn't work. I'm glad that this didn't work, actually. So what this has done has created the wrong graph. So if this pops up for you, no fear. This is not the right one, so I'm just going to hit delete. So spreadsheets are super smart, but they're also kind of literal, super literal, so that means they can be kind of dumb. So even though I've only selected what's in the blue sort of highlight here, it's trying to also include everything in between, and I don't want that. So if that's coming up for you, a simple solution is to just Command-C to copy or Control-C again, depending on your device, copy that information, and then just paste it somewhere far below. And actually, we don't want to paste just directly. What we need to do is actually you can go up to edit, or I just right clicked and do paste special, paste special values only, because you're going to have calculated numbers here. Like if you see here, I've done the function. Because they're calculated, when I tried to initially paste, what you may have seen initially is, sorry, it's giving me some problems. There we go. What I did initially, so Command C to copy and just pasting here, see how it gave me this error of reference? Because it's just trying to paste, you know, the actual, the function that I did here, and that's not quite correct. So just use paste special values only, and that will give you the correct information. Then from here, again, you just select the correct cells, insert chart. That's what I'm looking for here. So you should have the 3 locations on your x-axis and then temperature value on your left y-axis. All you need to do from here is change the title to be much more descriptive, add your name in the subtitle and axis titles. Note that our x-axis title is not sourced WeatherSpark. So again, to do that, you're going to go to Customize, Chart and Axis Titles, and this, you know, selection of drop downs is where you're then going to be able to make these adjustments. We learned how to do that in Lab 1, so if you need a refresher on that, please refer back to that particular video. I do have separate videos showing you how to calculate the average and calculate the range. So if you need those are linked separately, not only on the lab, but also on the Canvas shell. So you can access those to give you an idea of how to do those particular functions. And that's that's basically lab 4. So the following questions beneath what I just showed include summarizing all of that data and information, kind of putting all of these ideas together, what we've learned in previous labs, like Earth-Sun relationships, and what you learned at the beginning of this lab and such, to kind of bring it all together and form one nice cohesive paragraph, kind of explaining your thoughts. Also, I want you to readdress your hypothesis. Was your hypothesis correct? Totally cool if not. That's what science is all about. So it's a really neat sort of process of science. Yay! So once again, please let me know if you have any questions, comments, or concerns on anything. In the moment, don't submit a lab that's incomplete, that, you know, we're not understanding everything. Please come to me first so that we can make sure that you're actually understanding all of these ideas before you turn it in, right? So that's the whole point, yeah? So yeah, again, reach out if you have any questions. Thanks so much for watching, and like and subscribe. No, I'm just kidding. But I appreciate it. Have a great rest of your day. Thanks.